Hello everyone, I am Mustafa. Today, inshallah, I will show to you an easy way for tests for comparing the variance between groups. So this test is used to check the homogeneity of variance in R. We have, as you know, the homogeneity of variance is one of the important assumptions that we should take into consideration for example, when we apply the test for comparing between means by, for example, ANOVA. So the test of variance, we check it after as the second step after checking the assumption of normality distribution. Now we have two packages which are tidyverse and arithstatics, and two data frame, iris and tooth growth. The first test is Fisher. We can write it as this function var t-test, var dot test. So this function refers or relates to the Fisher test. The Fisher test is a test used to compare the variance between two groups, only two groups, and in the case of the normally distribution data. So the Fisher test is a test to compare between only two groups, to compare the variance if the variance are equal, or now between two groups. But these groups should have equal, or for example normality distribution, or follows a normal distribution. This we should, for example, put or write the dependent variable. In our case, tooth growth. The data, we have two data frames, tooth growth and iris. So the variable independent here is sub. Sub have two groups, and here we have species. Species is a variable independent here in data frame iris. Species have three groups. So as we know, var test, which refers to Fisher test, we can apply this test only when we have two groups. So in the data frame tooth growth, so we have, for example, len, which is a continuous variable, and sub refers to two groups. We put here first of all the len, which is the variable continuous or dependent variable, and we write after len the tilde, only one. The tilde is almost looks like the approximately symbol. After tilde we put the sub, which refers to, we can copy and paste here, which refers to the independent variable, and len is the dependent variable. After this command, we select the data, which is our data is the tooth. The T should be uppercase, tooth growth, like this, and click run. So in this case, the results of P indicates that the p-value is more than 0.05. The p-value is equal to 0.23, which refers to results that indicate that the two groups of the variable SIP, which is the variable independent, have heterogeneity variance of between groups. So the variance of those two groups aren't the difference, or the variance of this group aren't equal. So we can conclude that the assumption of homogeneity of the variance is not met. Secondly, after this function, which refers to Fisher test, we apply a Bartlett's tests. Bartlett's test. So sorry. We can paste or copy this comment that passed here for avoid the redundancy. The only difference between Bartlett's tests and the Fisher tests that the Fisher tests we must apply only in when the case of two groups, and Bartlett's tests we can apply it in the case of two or more groups. Both of these tests, Fisher and Bartlett's, most applying when we have normality in distribution of our data. So we click to run. In this case also the p-value indicate a similarity of results and the p-value of the Fisher test. So this refers to that the difference between the two groups, there is no difference between there is no difference on variance between two groups. So we can assume the homogeneity of variance. So this is the Bartlett test and the Fisher test. The third test is the Levene's tests. Levene's test, we can use it when applying this package. First of all, we should, for example, write the iris, which is the data frame %, and write the function of the Levene tests, Levene like that, Levene underscore tests, and we put here we can, for example, only copy this, for example, variable, which is the dependent variable of the data frame iris, and we put here the tilde. After the tilde, we should write the species, which is the variable dependent and compounds for three groups. So in this case, Levene's, we apply Levene's when we have three groups, and also the Levene's is more sensitive when the normality is not meted. So when the distribution avoid or distribution seems to be follows a non-normal distribution, we can also apply Levene's tests instead the Bartlett's tests. So we click to run. The results indicate of the p-value from the Levene's tests indicate that the difference between the groups of species is indicate there is a difference of variance between the group of species. So these tests, Levene's tests, we apply in these tests in the data frame iris, which compounds from the variable dependent continuous, which is sepal length, and the species is the variable dependent which have three groups. So the p-value significantly value of the p, which indicates that is a difference, significantly differences between groups of species. But now on the final test, which is the test of the Fligner Killeen's tests. Fligner Killeen's tests, and we can, for example, take this all command. But there is a twist. Fligner Killeen's tests is no parametric test. Is a robust test for the case of our data, for example, or our deviate from normality. But there is a twist. We should apply in iris tests, iris, for example, data, and we put there the sepal length, for example, or petal length as we want, and species as with uppercase species instead the sub, and we click to run. So the p-value in this case of the test of Fligner Killeen indicates that the p-value is less than 0.05, which indicates that there is a significant difference between groups. So the variance, the difference between groups aren't equal. or the variance between groups, variances between groups aren't equal, so we can conclude that the homogeneity of variance aren't met. So this is all of this lesson today. I hope that this will helpful for you, and if there is questions, suggestions, any comments, please flag any concerns immediately in the comments. And also pay attention. You can find all the comments here, all the comments below in the description.